Hello everyone, myself, Mr. Unknown, your guide, mentor, helper, teacher, whatever you say. So today we are going to discuss about metal and non-metal. It is class 10 topic, and today we will go deeper into this topic with from basics to advanced. And after this video I'll assure you that you will never get anything wrong in metal and non-metal. Whatever videos you see that will be just too basic or will be just too advanced, but this video will be just perfect for you for your science olympiads. Yes, you can give science olympiads on the basis of this because I'll not cover ncrt at all. I'll cover the concepts that are deeper, and I'll make sure that you understand every single line of the concepts deeply, not just any ratta, but understanding. So let's begin with basic things, that's elements. So what are elements? We know that elements could be classified as metal and non-metals. Okay, so what are metals? That you know that. See, before starting the video I am assuring that you have studied the class ninth completely properly, and even if you don't, then it will okay. I will just help you from basics to advanced. So elements are of two kinds. It is metal and there is non-metal, and this division is on the basis of the properties. There are 118 chemical elements known present to our periodic table, and there are similarities as well as differences in the properties of these elements. On the basis of their properties, all elements can be divided into two main groups, that is metal and non-metal. So metal are basically electropositive nature elements, whereas non-metals are electronegative nature elements. Now what is this electropositive nature means and what is this electronegative nature means? Basically, metal has a tendency to lose electrons, and if a element loses electrons, then the proton number will be greater than the electron number, and hence it will gain a positive charge. Whereas in a non-metal, it there has a tendency to gain electron, and hence their proton number will be less than the electron, and hence they will get a negative charge. That's called the simple thing. Okay, that's the basic difference between the metal and non-metal, and there are many physical and chemical relations or differences between them, but we will study them further. Now, metals are elements which form positive ions by losing electrons. As I said, that they will form positive ions, and non-metals will form negative ions. For example, aluminium is a metal which forms positively charged ion, that is Al3 plus, by losing electron. Okay, so that's why it is a metal, because it gains a positive charge. Now, one thing, that all metals are solid, at room temperature, except mercury. Mercury is the only metal that is liquid at room temperature, which is used in thermometers. Now, based on abundance of metals, we can write their abundancy in this way, that the most abundant metal in our Earth's crust is aluminium. Seven most abundant metal is our iron, that is first, that is second. Third most abundant metal is calcium. Fourth most abundant metal is sodium. Fifth most abundant metal is potassium. Sixth most abundant metal is magnesium. Magnesium. I'll write the symbol also. Aluminium, iron, calcium, sodium, potassium, magnesium. So this is the abundance means in Earth's crust, because Earth's crust is the major source of all the metals as well as non-metals. So in our Earth's crust, the most abundant metal is our aluminum. Then comes iron, then calcium, then sodium, then potassium, then magnesium. Sometimes some MCQs may come in the exam. And moving to our now non-metal side, we will get that non-metal are elements which form negative ions by gaining electrons. Basically, they are the acceptor of they are basically acceptor of electrons and form they forms they forms what? They forms negative ions. They form negative ions. Okay, and they form positive ions, metals, non-metals. Now, as I said about abundancy, if I uh, list the abundancy of non-metals, it will be like this: oxygen, then silicon, third is our phosphorus, then sulfur. That's it. That's just enough. So oxygen is our most abundant because it's almost 75% of air, as well as it is dissolved in water also, so it's everywhere. Second is our silicon. It is actually a soil, sand grains have this silicon. Phosphorus, it's our third, and fourth is our sulfur. Now, one thing to note, that is non-metals are lesser than metals in quantity. Quantity, not in number. Now, what does it mean? So basically, there are only 22 non-metals. Yes, you heard it right. There are just 22 non-metals at all. Just 22. Among the 22, we can divide them in three parts. We can divide them into three parts. First part is solid parts. That is 10. 10 non-metals are solid. One non-metal, that is an exception, is liquid. Okay, and remaining 11 non-metal are gaseous. Now, which one is this liquid non-metal? Can you remember it? Guess what? Guess. You have studied it. That's bromine. That's bromine. Okay, and it is the only non-metal liquid, and there is no other non-metal liquid at all. Remaining are just solid or gaseous. That's it. And it is important. See, non-metals are actually majorly very important because life is living on earth because of non-metals. Yes, because of non-metals. Life is living on earth because of non-metals, because proteins, fats, then carbohydrates, the oxygen we live on, the hydrogen, that is water made of, and we produce electricity of hydroelectricity, and vitamins, enzymes, these all are even fuels we burn, that is basically carbon compound, these all are non-metals. So can you imagine oxygen, the value of oxygen. And if I give you some example, for example, nitrogen is a inert gaseous non-metal, inert because it is not reactive at all, and it is present in our air as well, and it reduces the rate of combustion and makes it safe. Okay. And another non-metal is sulfur. It is present in many substances found in plants and animals. For example, sulfur sulfur is present in hair, sulfur is present in onion, sulfur is present in garlic, sulfur is present in wool, etc. Just imagine. Sulfur compounds are even in our hairs. Onion we eat daily, garlic we eat daily, the wool we wear, clothes. This all has sulfur compounds. So that's why non-metals as well as metals are both important. Okay. So we have completed that much. Now we will move to properties. Now properties are of two types. One is physical, another is chemical. I know it's just going too basic, but I'm going too bit tough and advanced as well. And one thing that I'll make a video of numericals separately. This lecture is just because of a revision, a complete theory base, and there will be no questions at all. So watch it to learn. And after that you can practice whatever book you want. You can do Strength, you can do NCRT, or whatever you wish. Oswaal. So how many physical properties are there? There are many physical properties. For example, malleability, malleability, then ductility, sonority, brittleness, then then you then conductivity, then we have lustrous, 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 then we have density, then state, hardness. Okay, and what except that can be other other like melting point, and boiling point. Boiling point. So you can see there are a lot of physical properties: malleability, ductility, sonority, brittleness, conductivity, lustrous, density, state, hardness, melting point, boiling point. And even there are even more. For example, if I say, if I want, I can add one more, that is color. So there are a lot of physical properties. We'll dive into all of them one by one. So let's first discuss about malleability. So what is this malleability? So so basically malleability of a metal means that it could be beaten into thin sheets with a hammer. Means if I suppose I have a piece of wire, then if I hammer it, then can I make it a sheet out of the wire? Can I make a sheet out of the wire? If yes, then it's malleable. If not, then it's not malleable. So not metals are generally malleable. For example, copper wire. For example, copper is a malleable thing. Actually, the best malleable substances are gold and silver, and we actually see them in daily life. For example, on top of sweets, and on top of uh, fake jewelry also, that they are made up of copper, and a thin sheet of gold or silver is coated over it, and we think that that's gold. Even detectors can't feel that it's fake or real. So how we can continue? See, gold and silver are the best malleable materials, whereas we have another one, that is aluminium, that is also used in our food packaging like biscuit, chocolate, medicine, cigarettes, etc. Milk bottle caps are also made up of aluminum foil. Okay, and gold and silver foils are not generally used. We can't see them regularly at all. And copper metal is also highly malleable, as I said. So copper sheets are used to make utensils and other containers. Iron is also a quite malleable metal which can be hammered to form iron sheets. These iron sheets are used to make boxes, buckets, dams, drums, and water tankers, etc. Now, after that, we have ductility. Now, what is this ductility? Ductility is basically the property of a metal which can be used to drawn a metal into a thin wire. Suppose I have a piece of copper, and if I can able to stretch it out and make a wire out of it, then this property is known as ductility. And in our regular life, copper and aluminium, these two are the most ductile materials we can see generally. ठीक है? Except these uh, gold and silver are also ductile metals. And the fun fact is that gold is the most ductile. Gold is the most ductile, but we don't use gold because it's, as you know, it's expensive, and even and if we use it in regularly, then आपको पता ही नहीं, चोरी करके काट के ले जाएंगे भाई. So it's not that effective at all. But next we have sonorous. Sonority, or it is basically sonorousness. So this is the property of a metal that can produce sound while if it dropped. For example, if I have a utensil that is made up of, suppose, stainless steel, stainless steel is an alloy. Now suppose I have iron. Now iron will produce sound, isn't it? It will produce sound if we drop it from a height. From a height, it will produce a sound, and that means it is sonorous. The materials, the elements which can produce sound when dropped, they are sonorous. Now, brittleness is basically metals are not brittle. Okay, so metals are actually can not brittle at all, but non-metals are. Non-metals are, ये वाला स्टेटमेंट आप याद रखना, ये वाला आप चाहे तो लिख सकते हो. It is very important. Then we have conductivity. Now conductivity is important. Conductivity contains two divisions, that is heat, that is conductivity of heat, and conductivity of electricity. Now most metals can conduct both heat and electricity. Most, I said most, not all. Most metals can conduct both heat and electricity, but there are some exceptions at all. um, for example, let me think. For example, copper, aluminium, they are a good conductor of electricity and heat as well. And one thing, that copper wire is used as in our home for current consuming, and there is a layer of insulation over it because to protect us from the direct contact, and this insulation is made up of PVC, that is polyvinyl chloride. That is polyvinyl chloride. Now, and one thing, that except except graphite except graphite, there is no other such non-metal which can conduct heat and electricity. Oh, sorry, electricity. Graphite can conduct heat. Now, after this, we have lustrous. Lustrous is the property of a metal to uh, shine, to reflect. So, metals are generally lustrous. Non-metals that don't, not. So, for example, if I say about metals, there are like gold, silver. If you polish it, or even without polish, they will shine. Then, like for example, copper also shines, aluminum also shines. So these actually all shines. Okay. Now there is an exception for non-metal, that is iodine. Except iodine, all non-metals don't shine. They are non-lustrous. Then for density, metals have high density than non-metals. Metals have high density than non-metals. For example, sodium and potassium have lower densities because they are light metals, but basically as they are called light metals, and hence they are the exception to metals. See, sodium and potassium, they are exceptions. They are called light metal. They are called light metals. Except these, all other metals are denser. For example, iron. The density of iron is 7.8 gram per cubic centimeter. Yes, that's the density of iron. And as of sodium and potassium is sodium is around 0.97 gram per centimeter cube, and for potassium is 0.86 gram per centimeter cube. That is the main thing. Now we have to move to state. See, I had already discussed about state in this, that non-metals are solid, liquid, gaseous. They can have both states, okay? But if I tell about metals, so metals are solid at room temperature except mercury. I also said that, and except that all metals are actually solid. Metals are generally not, metals are actually not gaseous at all. Then we have hardness. Metals are generally harder than non-metals. Exception, there is an exception, that is diamond. Diamond is the exception to this. Okay, now we will move to melting point and boiling point. See, in a metal, in a metal, the boiling point and melting point are higher than non-metal. Boiling point and melting point are higher, but there are also some exceptions, and that is sodium, potassium. There are exceptions here also. They have relatively lower melting and boiling point. For example, their melting point is 98 degrees Celsius and 64 degrees Celsius respectively. Okay, except these, we have other metals like gallium, cesium. There is also low melting point. Low melting point. Okay, even they melt with our hand temperature, that is body temperature, that is 37 degrees Celsius almost. Except this, if I tell about some very much high temperature, for example, if I take a case of iron. In case of iron, the melting point of iron is 1535 degrees Celsius, and if I say about copper, copper has a very high melting point, that is 1083 degree Celsius almost. Then we have color. Now all metals and non-metals are of different colors. Some may be uh, reddish brown. For example, copper is reddish brown. Then we can have gold, that is yellow color, or some may be colorless. Some may be colorless, uh, or some may have silvery or gray color, as silver, gold. Now I'll revise non-metal part a bit quicker. I'll just don't write anything. If not needed, I'll just speak. So if I tell about the non-metals, so non-metals are neither malleable nor ductile, as I said. Then non-metals do not conduct heat and electricity, as I said, except graphite. is a good conductor of electricity. The non-metals are non-lustrous means dull, they are dull, non-shiny. Then non-metals are generally soft except diamond. The non-metals are not strong, they break easily. So basically their uh, hardness or is not that much, they are not much strong at all. They have low strength. Then we have non-metals may be solid, liquid or gaseous, as I said, that are 10 are solid, 1 is liquid, 11 is gaseous. That's 22 animals. Non-metals have comparatively low melting and boiling points, as I said, but diamond is the exception for it. The non-metals have lower densities, that is, non-metal are light substances. Okay. For example, if I take about sulfur, it is only 2 gram per cubic centimeter. The non-metals are non-sonorous means they do not produce sound when hit or when of anything fall off from a height. Non-metals have many different colors, like they may be yellow as sulfur, they may be white as phosphorus, or red, then they may be black as graphite, they may be yellow green as chlorine, CHLORIN, chlorine, then they may be colorless like hydrogen and oxygen. Okay, now we will move to chemical properties. So first I'll explain the chemical properties of metal. So number one, met reaction of metal with oxygen, that is air. कैसा reaction? So when metal, I'll represent metal as M, reacts with oxygen, it goes into a chemical reaction and form metal oxide. And metal oxide is basic in nature. That means they will turn red litmus to blue. Mind it. Okay, so this is first point to be noted. Okay, for example, if I give an example, if I take sodium, that is a solid, and if I combine with oxygen, that is gaseous, we will get 2Na2O, that is solid. So this is an example you can give, and it's about the practice and memorization. See, potassium metal and sodium metal are stored under kerosene oil to prevent their reaction with oxygen, moisture, and carbon dioxide of air. Means sodium, potassium metals are stored. Even lithium also is stored in kerosene because they're highly reactive, and hence they react with oxygen, moisture. Moisture means water vapors, whatever you say. Then carbon dioxide in air. So they react in one word. They react in air. and hence they are reactive, and hence they are stored in where? They are stored in kerosene oil. Now, most of the metal oxides are insoluble in water, but some of the metal oxides dissolve in water to form alkalis. So, metal oxides are insoluble in water. Here, this means insoluble. So, insoluble in water. But some metal oxide dissolve in water. For example, there are some exceptions. Like if I talk about sodium oxide, then potassium oxide. These two are exceptions. If I give an example for the fourth, okay. So if I combine this with water and this also with water, it will form potassium hydroxide and it will form sodium hydroxide. And these both are alkali. That is basic. Basic in nature, base. Now, as they are base, they will turn red litmus to blue. Mind it. If I take about magnesium, so see, magnesium reacts with oxygen and gives out MgO, and we know that in this reaction heat and light is also produced. That's another thing. Okay, so we have covered a lot of things. Okay, now let's understand some amphoteric oxides. Amphoteric oxides. So amphoteric oxides are a metal oxide which show basic as well as acidic behavior. Means amphoteric oxides shows both acidic as well as basic nature. I can give example. For example, if I give example of mm, aluminum oxide. There is an element that is aluminum oxide, AlO, or we can have zinc oxide. Zinc oxide. These are very known amphoteric oxides. So basically, when they are reacted in with a acid, they produce chloride and water. Means if I react aluminum oxide with hydrochloric acid, then they will produce aluminum chloride and water. And the reaction is Al2O3 plus H2O, sorry, H2O not, HCl. It will give me AlCl2 plus H2O. You can balance it. So now see, now this ACl2, this thing over here is a salt, and this is water. You know that means here aluminum oxide. See, HCl is acid. That means here aluminum oxide acts as a base, if you have noticed. And if I add this aluminum oxide to sodium hydroxide, that is NaOH, that is a basic solution, then a strange thing we will notice that it will form sodium aluminate, that is NaAlO plus H2O. Now here this sodium aluminate formed over here is basically a salt, it is aluminate, and that is water. So that means this is a base, and hence here this react as a acid, and both get a neutralization reaction. Neutralization reaction, which is quite strange thing. Now I'll give some examples of these reactions. For example, of these reactions are aluminium oxide. As I said, Al2O3, zinc oxide, then lead oxide, tin oxide, then chromium oxide, Cr2O3. These are the examples of amphoteric oxides. So these are everything. Okay, now I think it's becoming a lengthy video, and just revise this much part, and I'll come sooner with part 2. Now what topics we will cover in part 2, let me say. So we will discuss number 1, full chemical property of metal as well as non-metal. Okay, second thing we will study is reactivity series of non-metals and metals. These two parts will be covered in our next part, that is part 2. Like, share and subscribe because it's free. I tried my best. Take care. Good night.